Good morning. Today is National Mathematics Day. This day is celebrated every year to honor the legendary Indian mathematician Sir Srinivasa Ramanujan. This day reminds us how mathematics helps us think clearly, reason better, and identify patterns that we often miss in our everyday life. When we arrange a number of items, the order matters. When there is a small number of objects, the number of possibilities is very small and we can reach the possibilities. But when the number of objects increases, the number of possible arrangements increase very quickly. For this, we use a counting idea called factorial. I am a student from standard 10 and I will be showing what factorial is through simple arrangements. Let us see the simplest case. Let us take only one object. Let this square be our object. Factorial of a number denotes in how many ways that much objects can be arranged. If I say 1 factorial, this value will denote that in how many ways one object can be arranged. There is only one object. This object can be arranged in only a single way. There are no other objects here. I can arrange this single object in a single way. So the number of ways one object can be arranged is 1. Now let us check 2 objects. The number of objects is 2. The number of possible arrangements with 2 objects will be given by 2 factorial. Let the circle be our another object. These two are our objects. Let us keep the square in the first place and the circle in the second place. This will be one element. I can keep the circle in the first place and the square in the second place. This will be another arrangement. In total, I am getting 2 arrangements. For 2 objects, there are 2 possible arrangements. So 2 factorial should give us 2. That is the number of possible arrangements with 2 objects. Now let us take 3 objects. We will do the counting a little bit different this time. Let us set the square in the first place. We will not change its position. I am left with 2 other objects, the triangle and the circle. Let us put the triangle in the middle and circle in the third position. This will be one arrangement. Keeping the square in the first place, I can alter the position of these 2 shapes. Let us put the circle in the middle and triangle in the third place. Keeping the square in the first place and altering the position of the 2 other shapes, I am getting 2 arrangements. Now let us take the circle in the first place. I am left with the square and the triangle. I can put the square in the middle and the triangle in the third position. This will be one arrangement. Keeping the circle in the first place, I can put the triangle in the first place, middle, and the square will be put in the third position. This will be one more arrangement. For the circle kept in the first position, I am getting 2 more arrangements. Now with the triangle, let us put the triangle in the first place. I am left with the square and the circle. Let us put the circle in the middle and the square in the third place. This is one arrangement. Keeping the triangle in the first position, let us put the square in the middle and circle in the third place. This is one more arrangement. Here I am getting 2 more arrangements. In case of 3 objects, the number of possible arrangements will be given by 3 factorial. Here I have got 3 sets of 2 distinct arrangements. That means the total number of possible arrangements will be 3 times 2, that is 6. Here we can see, if I take one object in the first place, I am left with 2 other objects. I have to arrange those 2 objects. In case of 3 objects, we are ignoring the first object and arranging the 2 other objects. We are doing this with all the objects. We are taking every object one by one, putting it in the first place and arranging the 2 other objects. In case of 3 objects, so the total number of possible arrangements will be given by 3 times the number of possible arrangements with the remaining objects. The remaining object is 2. So the total possible arrangements with the 3 objects, it will be 3 times the number of possible arrangements with 2 objects. So I can write 3 factorial as 3 into the number of possible arrangements with 2 objects, which is given by 2 factorial. It will be equal to 3 times 2 factorial, which is 6. Now let's get back to 2 objects. In 2 objects, what we saw, we are fixing one object in the first place and we are left with one more object. We are doing it for the other object as well. In case of 2 objects, we are putting each of the 2 objects in the first position, we are left with one object. That means in 2 factorial, it will tell us the possible number of ways for 2 objects. It will also be equal to 2 times the number of possible arrangements with the remaining object, that is 1. It it will be 2 into 1 factorial. That means 2 multiplied by the number of ways one object can be arranged. We know 1 factorial is equal to 1. So 2 into 1 factorial will be equal to 2 into 1. Here I can see it is 3 into 2 factorial. It will be equal to 3 into 2 factorial is 2 into 1, which will give me 3 into 2 into 1. 3 factorial is 3 into 2 into 1, or I can also say 1 into 2 into 3. 2 factorial is 1 into 2 and 1 factorial is 1. The pattern has got obvious. In case of n number of objects, to arrange n objects in a specific order, I can find the value of n factorial. This value will tell me in how many ways n objects can be arranged. From our experiment, we have seen that to arrange a certain number of objects, we have to multiply the number of objects by the possible arrangements with the remaining objects. In n factorial, I can write it as n into the number of possible arrangements with the remaining objects, that is n minus 1 objects. So n factorial will be equal to n into the number of possible arrangements with the remaining objects, that is n minus 1 factorial. 3 factorial we can see it is 1 into 2 into 3. 2 factorial is 1 into 2, 1 factorial is 1. So I can say n factorial will be equal to 1 into 2 into 3 up to n. I can also define n factorial as the product of all natural numbers from 1 to n. Now let's see an exceptional case. How many objects can we see here? 0. What will be the value of 0 factorial? 0 factorial will tell us in how many ways we can arrange 0 objects. If I say there are 0 objects now, that means there is nothing here. In how many ways this nothingness can exist? There is nothing to arrange, I cannot change anything. That means this nothingness is existing only in a single way. I cannot change anything, that means it has its own single way of existing. That means the number of possible arrangements for 0 objects should be 1. So from our experiment we can say 0 factorial is equal to 1, because 0 factorial will tell us in how many ways we can arrange 0 objects. This was the practical demonstration. Now let's take a look at the mathematical proof. We can see 3 factorial it is equal to 3 times 2 factorial. 2 factorial will be equal to 2 times 1 factorial. 1 factorial will be equal to 1 times 1 minus 1, that is 0. 0 factorial. From here I can say 0 factorial into 1 is equal to 1 factorial. We know that the value of 1 factorial is 1. It should give me 1. That means 0 factorial is equal to 1 divided by 1, which will give me 1. This was the mathematical proof for 0 objects. The idea of spotting patterns and building powerful formulas from simple experiments is what makes mathematics so beautiful. And with that, I would like to end my presentation here by remembering Srinivasa Ramanujan, the man who invented it. Thank you.